All right, so here's the development of the geometric sequence equation. The geometric means that you're multiplying, and you can see here this is multiplying by 2. If that weren't as obvious, the method that you would use is to divide any pair. So the 20 gets divided by the previous 10, it produces 2. Likewise, that's maintained if we pick any other pair. So the ratio, which is the word that we use to describe what we're multiplying by, the ratio for this pattern is 2. Now, this is going to be the first, second, third, and fourth number in the sequence. And when we go to write the equation, we're going to use only the starting value and how many times we're multiplying by 2. And here's what I mean by that. We can say that the first number is 10, but the second number can be expressed as 10 times 2. And the third number can be expressed as 10 times 2 times another 2, or 2 squared, if you will. And the 80 then would be 10 times 2 times 2 times 2. There would be 3 2's repeatedly multiplied. And then just so we have a pattern going here, we can see that the amount of 2's is growing. And furthermore, the amount of 2's is always 1 less than the term number. If we try to connect the pattern between the term number and the exponent, it's off by 1. And so when we go to make the equation for this, in general, this particular pattern, we take 10 and we multiply by 2 repeatedly. I'm going to put this in parentheses just to visually separate it. And the exponent on the 2 is the same as the term number, but 1 less. And so that would be the specific formula for this pattern that multiplies by 2 but starts at 10. And say, for example, we wanted to find the 12th number. Put here the 12th value in the sequence will be 10 times 2. And then since n is 12, this would then become 11 as an exponent, which is, go ahead, crunch that number, is 20,480. Okay, so that would be if we wanted to make a calculation for the numbers further on in the pattern without making the table out to that position in the pattern. Now, looking at what's going on here, we can go one step further and say, well, generally speaking, the general term is, this case, the 10 is subject to change. That's represented by U1. It's the first number in any one of these patterns. And then the 2 is also subject to change, but it's always the ratio of any pair. And so we're going to use the letter R to represent ratio, and then n minus 1 because the count is off. And the reason why the count is off is because we start at 1 as opposed to 0. And so that has to be factored into the whole equation. And so this is the one that we're going to use for the next part, establishing geometric sequences.